Okay, continuing on with our law of sines and cosines here. We want to do example 3. We've given a triangle and we know two of the sides and we know an angle. So the first thing we want to do is draw a picture of this. That's always a good idea. Let's just call this A, B, and C. This is angle A. Side C is across from it, and so that's 3. We also know side B is 2. And we know angle A is 40 degrees. So 40 degrees. Okay, so what we've got to do here is we've got to see, if you remember back to our cases, we have to see our different scenarios that we're looking at. So we know that A is bigger than B, right? So A is greater than or equal to B. So this means it's case, let's come back over here on our previous side. So we had A is less than H, A is equal to H, A is less than B, or A is greater than or equal to B. We've got case 4. There is only one triangle. So this is case 4, which means we're going to have an obtuse triangle. Okay, and the way we do this is if I'm trying to find this side, so side C, we also need to find angle B and angle C. We don't know angle C or side C, so for right now we need to stay away from using those. We're going to come over here and work with angle B. So as long as we know two sides and an angle, we can solve for the missing angle. So sine of angle A, so that's sine of 40 degrees, divided by side A, so that's 3, is going to equal the sine of angle B divided by 2, which is the side B. Okay, if we rearrange this, so cross multiply here, I've got 2 times the sine of 40 degrees equals 3 times the sine of B. Divide both sides by 3. And to find B, I'm going to have to take sine inverse. So sine inverse of 2 times the sine of 40 degrees, all of that divided by 3. So let's plug that in the calculator. Turn on your calculator. Again, make sure you are in degrees, which we are. And we're going to plug in second sine. And I'm going to do a second parentheses in here just to differentiate the top and the bottom. 2 times the sine of 40 degrees. Okay, close parentheses. So that's the end of the top, divided by 3. Close parentheses, and enter. And we have, again, we're keeping 2 decimal places, so 25.37. 27.37 degrees is angle B. Okay, so we've got angle B. If we know B and we know A, we should be able to find C, because A plus B plus C has to equal 180 degrees. So 40 plus 27.37 plus C equals 180. C must equal 180 minus 40 minus 27.37, 112.63 degrees. Okay, and yes, that is obtuse. So great, that is what we thought it was. I hope you caught what I just did. I made a mistake here when I was subtracting this. So 180 minus 40 minus 25.37, and we get angle C is 114 degrees and 60.63. So there we have our angle. So we now know angle A, angle B, angle C. So let's go ahead and put those, well, we don't need to put them in there. I still need to calculate what length of side C is. So I'm going to have to do another law of sine. So I'm going to do sine of 40 degrees. So sine of angle A divided by side A is going to equal the sine of angle C, 114.63, divided by the length of C. Again, if we cross multiply here, I'm sort of running out of room, I'm afraid. So if we cross multiply here, let's just put this on another piece of paper so I have room. So I would get c times the sine of 40 degrees equals 3 times the sine of 114 degrees, 0.63. Divide both sides by sine of 40. And that would give me what side C is. So let's go ahead, clear out our calculator. Now I'm going to put a parentheses around everything in the top to make sure it's all getting divided. So parentheses 3 times sine of 114.63 degrees, close parentheses, so that's everything in the top, divided by sine of 40 degrees, and enter. So side C is 4.24. We now have solved this triangle. We know every side and we know every angle. So again, solving means finding all three sides, all three angles. Okay, and let's come back to this next one. Example 4. We are given A, B, and angle A. So again, we've got to look. Is A bigger than B? No, it's not. So if it's not bigger than B, I need to check and see what the height is. If you remember, height is equal to B times the sine of our angle. So B is 8 times the sine of 35. 8 times the sine of that, 8 sine of 35, gives me 4.59. So that's my height. So it looks like we have got, let's see, I want to compare my height, my side B and side A. So looking at our cases here, is the height less than A? Yes, it is. Is A between your height and side B? It is. So we're looking at this case. The height is less than A, which is less than B. This is case, therefore, this is two triangles. This is what's called your ambiguous case. Okay, so we've got to draw two potential triangles here. First triangle, this whole thing's going to be length C. Oops, that's not going to be very accurate there. So I could have this come down here, or I could have it come here. This whole side is C. This is A, this is A, this is B. Angle A is there, angle B. So there's two potential angle B's, and then this is C up here. Okay, so if I'm looking at this, let's see if we try. I've got this, or if I look at this small one, the skinny one, I would have it looking like this. And I'm going to call this B prime. That's still A. This is B, this is A, this is C prime right here. This angle right here would have to be C prime. Okay, so there's two potential triangles. There's this big one right here, where this whole side is C, and then I have the skinny one, this triangle. I don't know which one it is. So we've got to calculate both. So let's do our big triangle first. Big triangle, this one. Okay, so if I want to find, let's see, angle B right here, I'm going to do the sine of angle A, because I know angle A is 35. Sine of 35 over side A. So this is sine of A divided by length of A is going to equal sine of B, which we don't know, over little b, which is 8. Okay, again, if we do the math here, cross multiply, so 8 times the sine of 35 equals 6 times the sine of B. And let's continue this on the next video.